Does the time flow, or do we just think it is because our brain works weirdly?
What's moving then? Me or the universe?
To find out, I read a few books about time. They confuse me even more. Let's look at this one together. In physics, many equations like Newton, Maxwell, Schrödinger don't care if time goes forward or backwards. You can change the sign of t to minus t, equations still work, and you can calculate things backwards. That's called t-symmetry or time symmetry. You also may have heard about this idea under the name Eternalism, B-time or block universe. That's philosophy. In block universe, the past, present, and future all exist and are equally real. Time doesn't flow, we just move through the block. The opposite is presentism, when only present exists. But I'm rushing a bit here. The first question that come up, why do these physics equations show a time-symmetric universe, yet you and I experience time moving forward? Well, it's because entropy is going up. The universe began at this special low entropy state, and the entropy is going up. This process creates a direction of time. Right, but why the entropy was low to begin with? Well, it's just kind of assumed. This assumption is called the past hypothesis. But not everyone is happy with that. And that's because, on one hand, some laws of physics, like Newton, Maxwell, quantum, say the time is symmetrical. And on the other hand, thermodynamics says time flows in one direction only. So which one is that? This is known as Lock-Schmidt paradox. But beside my personal complaints, many physicists object to the past hypothesis. Why are we just arbitrarily assuming boundary conditions? Why not future hypothesis then if the universe ends at some low entropy state? Also, Roger Penrose, in his book The Road to Reality, says that gravity complicates the standard thermodynamic explanation. Gravity wants to clamp things together, and the past hypothesis is incomplete unless it specifically addresses gravitational entropy. And then there's also quantum mechanics. That's another big mess. So in modern physics, scientists say that time is not just about energy or entropy spreading out, but it may be about quantum information loss. You might have heard quantum physics says that observer changes reality, or something dramatic like that. But all quantum mechanics really says, one, we derive this function, wave function, that predicts all possible futures. For some reason that nobody yet fully understands, it cannot tell you exact future you will see, only probabilities of all possible futures. Two, we experiment, we measure, one future appears. Three, it seems like by measuring, we disturb the system. But there are other systems that we cannot interact with without altering them, like stock market, for example. If you act on the information and trade, you're disturbing the stock market and possibly changing prices. Or another example is the observer effect in social psychology. If you want to record someone, they will act as if you're recording them. The point is, we are deeply intertwined with the system. But then if you try to interpret what this actually means, there are too many questions. Like, why do we see that one future and not the other ones? Were other futures even ever really possible? That's the measurement problem. And this is a big fight too. There are more than 35 interpretations of quantum mechanics. But generally we can separate them in two groups, collapse and no collapse interpretation. The difference is, do you believe quantum mechanics is a blurry picture of sharp reality or a sharp picture of blurry reality? Collapse interpretation says when you try to measure the system described by this wave function, you force it to pick a future and collapse in one outcome by some spontaneous real process. That's Copenhagen interpretation. If you also believe that collapse is real physical process, then the block universe falls apart, because that means the future doesn't exist until it's defined by this spontaneous process. Collapse creates a future. That's presentism. There are some other spontaneous events like spontaneous symmetry breaking. It's like when system gets stuck in a particular state that you cannot roll or calculate backwards symmetrically, and creates stuff like time crystals. But that's for another video. There are many versions of no-collapse interpretations, like many worlds, many minds, hidden variable, or shut up and calculate. That's a real one. But the key idea behind all of them is decoherence. Quantum systems decohere naturally, becoming classical by mixing up with the environment, air molecule, heat. The environment measures everything on its own without the need for the observer. When we try to measure, we only disturb the system state more by shooting particles at it. From our perspective, the transition from quantum to classical seems spontaneous, but that's due to our ignorance. Collapse is the moment our fuzzy picture becomes sharp. We know more about the system past than the system's future. Therefore, we humans experience the illusion of time. And unlike collapse interpretation, decoherence-based interpretation can exist in a block universe. Because in principle, if you were to track every interaction, you can reverse things and calculate them backwards, kind of like with entropy. But there's still too many questions with decoherence. Like, why do we see that one outcome and not the other? Or even crazier, not a combination of all of them? Is there a threshold at which quantum becomes classical? So all those interpretations exist trying to resolve this measurement problem. And they all answer these questions differently. There's this other crazy idea in physics that says time only exists when things entangle. Like one thing acting as a clock for the other thing. And events only happen in relation to each other. So unentangled things wouldn't experience time at all. And like the world would appear frozen. It's kind of a strange thought, and it's tricky to test in the world where everything is already entangled with everything else. Okay, so putting all this together, decoherent thermodynamics and mechanisms like Page-Wootters and post-hypothesis in cosmology, can we get a rough story for the era of time? Actually, we still don't have a complete coherent explanation, because remember, quantum mechanics and the theory of relativity, especially general, don't work together. In quantum mechanics, time is fixed, uniform, kind of on the background, and external to the system. But in relativity, time warps, dilates, depending on the observer's speed and proximity to the mass. For the physics to be complete, these theories have to work together. So to conclude, does the time really flow, or does the past, present, and future all exist at once? Well, I think the past and future exist, and I like eternalism. There's just too many evidence that no global time exists, and also no real now exists. There are different local times depending on the speed of gravity, on quantum system entanglement. And it makes sense that we can't see all the information. We're stuck observing the universe from inside the universe. Every moment of our experience happens in time. We study time from within time. Like someone said, when we listen to the music, the idea of music only makes sense in time. But if we're always in the present moment, then there's only one note at a time. So how is it possible to hear music? Well, it's possible because our consciousness is based on memory and anticipation. So to understand time, we not only need to understand quantum mechanics, thermodynamics, and relativity, we need to understand our brain. But that's too much for me right now.